Alright, so this is going to be another u sub, so we're going to do cup. So C stands for what I care about. I care about what my u is, my du is, my dx, and my x. So in this case, I usually tell you to ask yourself, what is the most trickiest looking thing to integrate in this problem? And it was probably going to be this. But here's the thing. When you have a fraction, you want to focus on what's on the denominator and make that your u, the most complicated thing there, your u. So in this case, I'm going to make tangent of x my u. And my thought process is, the whole point is when we calculate dx, the denominator of dx is going to contain something that's going to cancel out with the numerator. That's the hope. And so if you put in something like secant squared over here, when we get to this point, it's obviously not going to be the same thing because we're going to have to take the derivative and stuff. And so we want something that we know is going to get us to secant squared over here when we take derivatives. And we know tangent can do that. So then my du is just going to be my derivative of u, so secant squared of x times whatever's here, so that's dx. And then my dx is going to be taking this and solving for dx, so that's going to be du divided by whatever's next to the dx. I don't solve for my x, especially if I have trig. I never do that when I have trig. And then at this point, this u part in cup is to put everything in terms of u, and that should remind you that you have to also put your bounds in terms of u. Because right now we have the integral from x is equal to 0 to x is equal to pi over 3. We want those in terms of u. So I go back here and I do a little extra step. So x is equal to 0, x is equal to pi over 3. So what are the u equivalents? Well, I just plug in the x's in here. So tangent of pi over 3 and tangent of 0. And you can't leave your answers like these on your exams. You have to actually evaluate them. So remember, 0 is over here. This is 1, 0. So tangent is just sine over cosine. So it's going to be 0 over 1, which is just 0. So this is 0. And then pi over 3 is over here. I remember it because pi over 2 is here. So pi over 3 is right next to 2, so that's how I remember it. And then the way I remember the coordinates is this goes 3, 2, 1. So this is going to be 1/2, and then it's like 1, 2, 3. So square root of 3 over 2. And everything always has a 2 in the denominator, so we're good there. And so again, it's going to be square root of 3 over 2 divided by 1/2, which is the same thing as multiplying by the reciprocal, which is just 2. Cancels out, you're left with square root of 3. So this is square root of 3. Then I put everything in terms of u, including my bounds. So that includes my 0 and square root of 3. And then I'm going to have secant squared of x. And I know that's not in terms of u just yet, but the whole point is that whatever's in the denominator of my dx is going to cancel that out. So then I have 2 plus u because I made tangent of x my u, so that's going to be u. And then my dx, I solved for here is du over, guess what, secant squared of x. Isn't that beautiful? These cancel out, so you're essentially just left with 1 over 2 plus u over du. Now here's the thing that's new that I haven't introduced. You could do a double u sub. In this case, you would do another letter, but what I like to do is look at this and I'm like u, du, dx, and x, but then I change the variables. So this here, I'm going to change to w and then dw. And then these, remember this variable here and this one too has to be the same as your problem. So this is going to be du and then u. It's the whole point is you want to put now everything in terms of w. So really u sub is like any letter sub. Like you could just substitute with any letter. Like it doesn't have to be u, guys. So we're going to do w. In this case, I'm going to make my w the denominator. So 2 plus u. And then I'm going to take the derivative of that, which is just 1 times du times whatever's here, and then this is going to be dw. You just take this and solve for du, and I don't solve for u, and then we put everything in terms of u, and then that should remind you, oh wait, that includes my bounds. I have u is equal to 0, u is equal to square root of 3. I want to put this in terms of w now. In this case, we have 2 plus 0, which is just 2, and then we have 2 plus square root of 3. We have 2 and then 2 plus square root of 3, and so then we have 1 over w, because remember I made this my w. So then I have du, I can replace it with dw. And so now I have a really nice integral. And so this one we need to know the antiderivative of. It's the absolute value of whatever is in the denominator. So it's going to be w. And then that's all evaluated from 2 to 2 plus square root of 3. And then the p is plug your, I guess in this case it's not u, but it's your variable back in. So in that case, it's going to be ln of 2 plus square root of 3 minus ln of 2, and that is your answer to this integral.